Today we're going to be writing functions again, but this time we're going to be writing them from word problems. Now before we get started, I just want to let you know that there are 4 different types of linear equation word problems, and we're going to look at each of those separately. So to begin with, if we are given the rate of change and a starting point. When I am given my rate of change, remember that that is represented by m. So I'm going to be given something that says every day you have something, or for each, or per, or something that indicates of how much something is changing over time or how much something is changing repeatedly. And then I'm going to be given a starting point. And that starting point can be represented by the point 0b, or my y-intercept. They might say Johnny starts with $10 in his bank account. Or it might say that the initial fee is $30, or etc. So the equation that I'm going to use is just a slope-intercept form, which is y equals mx plus b. I can just plug in my m because I know it from here, and I can plug in my b. And there's no extra steps. That's all I have to do. So let's go ahead and look at an example. Angie's school is doing a run-a-thon fundraiser. Her aunt has pledged to donate $20 plus a quarter for each lap that Angie runs. Write and solve. Okay, and I'm going to focus on this right part first. So I'm going to write a linear equation. I'm going to write an equation to begin with. So let's go ahead and begin. Notice as I'm reading this, the information that I have. $20 is a starting value. Okay, she gets $20 no matter what. And then it says a quarter for each. Remember, there's my repeated added value. So this right here is my rate of change. So this is my starting. This is my rate of change. So I have that first case, and I can use, if this is my starting value, this is my y-intercept, and this is my m. So let's go ahead and write our equation. Y is equal to, my slope is 0.025 because a quarter is 25 cents, x plus 20. Now, some people might rearrange it and write 20 plus 0.25x. That is perfectly acceptable as well. Now, let's answer the second part of this question and solve the equation to find out how many laps Angie would need to make $50. Okay, you need to make sure you ask yourself, is $50 an input or an output? Okay, if she's making $50, okay, that is an output. Okay, we input how many laps she runs, and we output the cost. So 50 is equal to 0.25x plus 20. And to solve, I'm going to minus 20 from both sides. And I have a result with 30 is equal to 0.25x. And I'm going to divide by 0.25 on both sides. And that is going to give me x is equal to 120 laps. All right. Next example. To rent a bike at the beach, it costs $30 plus $7.50 per hour. Hey, here again I have a starting value. There's my B, and there's my M, because I notice it says per hour. That's how much I'm adding repeatedly to my starting value. So Y is equal to, I just like to write 30 plus 7.5x. 30 is a one-time cost plus 7.5x. I put the x because it's repeated. So there's my linear equation, and now I'm going to use it to solve my problem. So I'm renting the bike from 2 to 5:30. Find the total cost. Well, from 2 to 5:30 is, so 3 o'clock is 1 hour, 4 o'clock is 2 hours, 5 o'clock is 3 hours, so 3.5 hours. So 3.5 hours. Well, is that an outcome or is that an input? Okay, well, remember, if I input the how long, I get an output of the price. So y is equal to 30 plus 7.5 times 3.5. Oh, this one's definitely going to require a calculator. 7.5 times 3.5 is 20, so 30 plus 26.25. So it's a total cost of $56.25. All right, so those are examples of when I have a rate and a starting value. Next, let's talk about, I'm going to skip those examples. Let's talk about 1 point and a snapshot in time, which is a snapshot in time and a rate of change. So again, as I'm reading, I'm going to have a snapshot in time. So for example, at 2 hours, you are 5 miles up the hill. Or for 2 boxes of Oreos, it costs $7. So, and that gives me an input and an output value. So X, Y. And a rate of change, M. And they're still going to say, and each box of Oreo costs $8. How much else do I pay? So let's go ahead, and the equation that I'm going to use is up to you. You can either use the slope intercept, and by that I mean the B method, or you can use the point slope formula. Remember, that is y minus y1 equals m times x minus x1. And the B method would use y equals mx plus b. I'm going to use the point slope method. It's my favorite method, but you're welcome to use whichever one you like. So let's read. Martin has been charging $15 per lawn. Ding, ding, ding. That is a rate. That is my M. Notice the per lawn. To mow lawns over the summer to save money. After mowing 23 lawns, Martin has $435 in his savings account. Okay, notice it doesn't say he starts with 435. So this isn't a starting value. It's saying at 23, he has 435. That is an input and an output. So that is an ordered pair. Now, before you jump gung-ho about my ordered pair, what way to write my ordered pair, before you just plug in numbers, make sure you think about what my input and what my output would be. Okay. Remember that the input, or the independent variable, okay, is the thing that you have control over. Martin has control over how many lawns he mows, and the outcome is how much money he saves. So 23 is going to come first, 435 is going to come second, not just because it's in that order in the sentence. My M is equal to 15. So I'm going to use the point slope formula. Here's X, here's Y, and here's their 0.1. So Y minus 435 is equal to 15 X minus 23. Let's go ahead and solve. Y minus 435 is equal to 15x. 15 times 23 is 345. Let's continue to solve. I'm going to add 435. So negative 345 plus 435 gives me a grand total of 90. So y equals 15x plus 90. That is my equation. And now I'm going to figure out how much he needs to mow to make $750. Remember, we decided that $750 is the output. So that goes where the y is. 750 equals 15x plus 90. Solve that. 750 minus 90 is a grand total of 660 divided by 15 is a grand total of 44. So he mows, remember X stands for lawns, so he mows 44 lawns. Okay, take a second on this next example, pause and try it by yourself. All right, a cable company charges a service fee to come to the house plus a $60 per hour. Hey, that's my rate of change. So M is equal to 60. Automatically, I know. If the total bill was $205 for 3 hours of work, write and solve an equation. Okay, we're going to go ahead and write and solve our equation. So I have my rate of change. Now, this information right here is a specific snapshot in time. They're saying, hey, for $205, they work 3 hours. Now, when I go to write my ordered pair, remember, don't just write 205 first because it comes first in the sentence. What do you have a choice over? Does the cable company have a choice over how many hours they work? Hey, or the bill? Hey, they have their choice about how many hours they are there. So 3 comes first as my X and 205 is my Y. On this one, let's go ahead and use that slope formula again. Point slope formula. Y minus Y1, so here's Y1, 205 is equal to 60 is my slope, X minus X1. Let's go ahead and distribute. 60X minus 180 equals Y minus 205. And to solve, I'm going to add 205 to both sides. And I'm going to double check this with my calculator. Negative 180 plus 205 is 25. Now it says, what was the service fee? Remember, the service fee is for not working at all, so for 0 hours. So if I plug in a 0, Y is equal to 25, or in other words, that's always going to be my y-intercept. So $25 is my initial service fee. Okay, the next type of problem is a snapshot, 2 snapshots in time. So instead of being given a rate or saying per every each, I'm given 2 points in time. So x1, y1, x2, y2. And I need to use the slope formula because I'm not going to have my slope. So y2 minus y1 divided by x2 minus x1. Then I'm going to use either the point slope or the B method. Hey, pick your choice. Either way, I want to write my final answer is in slope-intercept form. So here we go. An antique vase was worth $185 when you inherited it from your grandma in 2007. In 2017, the vase is worth $325. Write and solve an equation. We're going to start with the writing and solving an equation part. Now notice it doesn't say anything about how much the price is increasing over time. It just gives me 2 snapshots in time, specifically 2007 and 2017. So let's go ahead and write our ordered pairs. Again, please make sure you don't just choose the first part of the sentence to be my input. Remember, time is always my independent variable. Okay, so I have 2007 is paired with 185, and 2017 is paired with $325. So my first step is to calculate the slope. So 325 minus 185 divided by 2017, minus 2007. So I'm going to go ahead and subtract the top part of my fraction. 325 minus 185 is a grand total of 140. My denominator, 2017 minus 2007, is 10 years. So that simplifies to 14. There's my M. Now you can choose the B method or the point slope method. I'm going to go ahead and use the B method this time because I've been using that point slope method so we get practice with both. So I'm going to start with y equals 14x plus b. I don't know what the starting value of my vase is. So I'm going to go ahead and I'm going to plug in some values. I'm going to pick the smaller values because I like to deal with smaller numbers, but either way, it's up to you. So my y value is 185 is equal to 14x. So I'm going to times by 2007 plus b. So here we go. 14 times 2007 is a very large number. Make sure you're using your calculator. I'm going to minus that from both sides. 1,998. So here we go. 185 minus 280, 98. Whoops. 0.98 equals b is equal to negative 27913. Now remember to write your equation. That's what I finally want. Now if you're thinking that that's kind of a strange number for my y-intercept, imagine that that's what the price would be way back at year 0. Okay, does it make sense? No, not really, but in order to get my equation to work the way it should, it's going to be kind of funky. So how much is the vase worth in 2025? Hey, I'm going to plug in 2025. 14 times 2025 minus 27913 equals 437. So in 2025, the price is going to be $437. All right, let's try one more example like that. After selling 15 lemonades, Jessica made $5, and after selling 42 lemonades, she made $18.50. Write and solve an equation to find how much Jessica spent on supplies. So let's go ahead and get started. I'm going to have 2 sets of ordered pairs. So my input, what does Jessica have control over? She has control over how many lemonades she sells. So 15, and the output is 5. She sells 42, and the output is $18.50. Let's go ahead and solve. I am going to go ahead and find my slope. So 18.5 minus 5 divided by 42 minus 15. 18.5 minus 5 is 13.5. 42 minus 15 is a grand total of 27. Please do not leave your slope as a weird fraction decimal thing. 13.5 divided by 27 is a grand total of 0.5 or 1/2. You can write it either way when I'm dealing with if I don't have to graph it. So far I have y equals 1/2 x plus b. We're going to use the b method again on this. I don't know how much my y-intercept is. If they sell no lemonades, I have no clue how much I have. So I'm going to go ahead and I'm going to pick a point. This looks easier to use, and I'm going to plug it in. So 5 is my y, 1/2 times 15 plus b, multiply. 1/2 times 15 is 7.5 plus b is equal to 5 minus 7.5 minus 7.5. b is equal to 5 minus 7.5 is negative 2.5. So y is equal to 1/2 x minus 2.5. Now you might be saying, hey, that's kind of weird that my y-intercept is negative 2.5. Well, Jessica had to buy the lemons, she had to buy the cups, she had to buy the sugar, and so her initial cost was, she was in the whole money.